Processing images, sounds, and video from the command line is rarely the most productive way to use the command line and to process such data. I admit that although I love working with the Unix command line tools, I very seldom processed media files with them. However, the corresponding command line tools can be remarkably effective when we want to automate operations among a large number of files. Before getting to our main dish, let's see first some commands that allow us to manipulate parts of a file's path. These come in handy when we process media files because we often move them around or change their file extension.
The most useful command in path manipulation is basename. In its simplest form, basename takes as an argument a file path and outputs just the file name without its directory components. Here, running basename on home DDS photos image0023.jpg outputs just the file name, image0023.jpg. In addition to a file path, basename can also take as an argument a file extension. This removes the file's extension. See here how we only get image0023. On the other hand, the dirname command, given a complete file path, removes the file name and returns the file's directory path. In addition, given a relative file name, we can use the readlink -f command to retrieve its complete path. Readlink is also used for dealing with symbolic links. What is a symbolic link? It is a special Unix file that points to another file, similar to a Windows shortcut or a macOS alias. To create a symbolic link, we use the ln command, which stands for link, with a -s option for symbolic. What follows is the target. This is the existing file we want to create a link for. Here, I enter the file /etc/motd, which contains the computer's message of the day, which users see when they log in. Then, we need to specify the link name, which will point to the target. In this case, I choose daily message. Catenating daily message, we get the actual contents of the file etc.motd. To see where daily message points to, I use the readlink command with daily message as an argument. As expected, we get /etc/motd. Now, let's combine all the above commands in a rather convoluted way in order to display a file's path with a different extension. This can be useful if we pass the path as an argument to an external graphical file editor. We'll use the above file, image0023.jpg. First, I store its complete path using readlink in a variable named f. Then, I echo the dirname of f, followed by its base name with the JPEG extension removed, followed by .png. In this way, we get /home DDS photos image0023.png. We see that the file's extension was changed from JPEG to PNG.
A venerable tool for dealing with image files is the NetPBM toolkit. This is based on a very simple idea, a single file format that each command will generate and read. Building on this, we have many simple tools that can use this file format. Each tool implements a single operation, such as reading from another file format, changing an image's scale, or converting its input into another format.
For example, to convert a file from the tagged image file format, TIFF, into the PNG format, which is commonly used on the web, we run two commands. First, I run TIFF to PNM on the file image.tiff to convert it from the TIFF format into the common denominator PNM file format. PNM stands for Portable Nmap format. Then, I pipe the output to PNM to PNG, sending the final output to image.png. That's how I convert the file from PNM to the PNG file format I initially wanted. This process may seem rather cumbersome compared to loading the file on an image manipulation program and then saving it again into the desired file format. However, it enables efficient automation, which is more difficult to achieve on graphical programs. In this way, supposing I own a collection of TIFF files, I iterate through them in a for loop. For each file, $i, I run basename on it to obtain its PNG name by replacing its diff extension with PNG. I store this in the variable PNG name. Then I run tiff to PNM on $i, converting the image to PNM format. In the end, I run PNM to PNG, sending the output to the name stored in PNG name in order to create the new PNG image file. What's more, we can combine multiple capabilities of NetPBM to create more complex pipelines. For instance, I first convert image.tiff into the PNM file format. Then I use another command named PAMScale to change the image's width to about 1000 pixels. I complete the process by converting the image from PNM to PNG, which is the desired format. As another example, consider the task of rotating the image of a license plate stored in JPEG format. Using the command JPEG to PNM, I convert it from JPEG to PNM. Then I use PAMFlip to rotate the image counterclockwise by 90 degrees. Similarly with the above, I scale the image with PAMScale to about 1000 pixels. Finally, I pipe it again to PNM to JPEG to write it out in its rotated form.
This is the image of the original license plate. This is the license plate rotated counterclockwise by 90 degrees. With the SOX suite of tools, we can manipulate sound files from the Unix command line.
I've already used the SOX command to create a small audio file. Let's play it with the -Q option for quiet mode.
SOX is a command line utility for converting and processing audio files.
SOX allows us to convert between file formats. To do that, we run SOX specifying first the file name with the original extension and then the file name with the new extension. Here, SOX converts the audio file from the uncompressed WAV file format to the lossy compression MP3 format. Listing the two files, we observe that the MP3 format is about 1/10 of the original WAV format. Furthermore, we can convert the file's pitch with the pitch argument. In this case, I reduce the pitch by 600 cents. Let's listen to the sample now.
SOX is a command line utility for converting and processing audio files.
It's also possible to change the tempo with the tempo argument. Here, I increase it by 50%. Let's listen to the difference.
SOX is a command line utility for converting and processing audio files.
As another example, I apply the chorus command. This modulates and delays the audio, making it sound like a chorus. Here's the output.
SOX is a command line utility for converting and processing audio files.
Now, let's add some sound to the sample. First, get a file from the web. Then I trim the file to 6 seconds, appending a 1-second fade out to the end. This is the output trimmed sound. Finally, I use the combine argument to mix this sound with the original audio file. Let's now hear the mixed sample.
SOX is a command line utility for converting and processing audio files.
This concludes our unit on processing images and sound. Stay with us.